Hello students, Jai Swaminarayan. Today we are going to start the new chapter surface area and volume. Now in last chapter we have seen how to find the area of triangle using Heron's formula. Yes, but triangle is a plane figure, two-dimensional figure. Here in surface areas and volume we are dealing with solid shapes, that is three-dimensional figures or three-dimensional shapes like cube, cuboid, cylinder, then cone, then sphere and hemisphere. Yes, so what is the need to find the surface areas, or what are the uses of finding the surface areas? First of all, we are dealing with the areas only. So what are the uses of finding the surface areas? Why we should know how to find the surface areas of the solid shapes, that we will see first. Now when we are talking about surface areas, there are two types of surface areas. One is total surface area. Total surface area, what we are calling it as TSA, and the other is lateral surface area. In case of curved surfaces, it is curved surface area. So lateral surface area, that is LSA. Now what is the meaning of total surface area and lateral surface area? Let us see with an example. Here this is a cuboid. Yes. Now we will see what is the total surface area. It is nothing but the sum of the areas of all the faces. Here the cuboid, how many faces it is having? 6 faces. You know, this is front, this is back, then 2 side faces, top and bottom. In that way, cuboid has 6 faces. So if I will find individually the areas of all the 6 faces, and then if I will add it, then I will get TSA or total surface area of this cuboid. So hope that you have understood the meaning of total surface area. The sum of areas of all the faces of this shape is nothing but the total surface area. Then what is lateral surface area? So if I will exclude the area of top and bottom, so how many faces then it is remaining? Here 4 faces are remaining. So the sum of areas of this remaining 4 faces excluding top and bottom is nothing but the lateral surface area. Here in this case, back surface, front face, then 2 side faces. If I will find the areas of all these 4 faces and if I will add it, then I will get lateral surface area of this cuboid. So in that way we can find total surface area and lateral surface area of the solid shapes. In this chapter we are studying the areas, surface areas of cuboid, cube, cylinder, cone, sphere and hemisphere. Last year we have dealt with this cuboid, cube and cylinder, and even we have seen or we have derived the formula to find the TSA and LSA of all these shapes, cuboid, cube and cylinder. Today we will discuss how to derive the formula to find the CSA, because cone is having the curved surface, so in that case we are calling it as CSA. So CSA and TSA of cone and surface area of sphere. Now let us see how to get the CSA and TSA of cone. So many conical shape objects we have seen around us, that ice cream cone, then tent, then joker's cap, all these are conical in shape. Yes, the cone is looking like that, wherein what this point, it is called as vertex of the cone. Then this is radius of the cone denoted by R. This is height of the cone. Now what is the height of the cone? It is nothing but the line segment joining the vertex of the cone to the center of the circular base, that is perpendicular height, that denoted by H, and this is slant height of the cone denoted by L. Okay. Now there are two terms, CSA and TSA. So what does CSA? Now if you will see, this is the curved face of the cone. So only the area of this face, curved face or curved surface, is the CSA of the cone. And then what is TSA? So if we will add the area of the base, circular, which is circle in shape or circular base, to that CSA, then we will get the TSA of the cone. Now let us try to find the CSA of a cone. Now for that, what we will do, we will take a circular shape or a circular piece of paper and then mark the point A and B on its circumference, and then join this point to the center of the circle. In that way we will get two line segments OA and OB, which are the radii of that circle, and we will take this as L, the radius of a circle as L, like this. Yes, we have joined these points OA and OB, and what we are getting now here, OAB, is nothing but a smaller sector. Then what we will do, we will cut out this portion or this smaller sector from that circle to get the shape like this. Yes, now here this is point A and this is point B. If we will bring these points together, yes, in that way, then what we are getting is nothing but the CSA of a cone. Yes, when I will bring these two radii together and will bring that 2 points together and will join like that, then what I am getting, if you will see, this is nothing but the CSA of the cone. Now how to get the formula to find this CSA of the cone? Yes, for that what I will do, I will cut this. Now it is a major sector of a circle. So what I will do, I will cut it into, or I will divide it into so many small triangles. Yes, like this, so many small triangles. Now here, in such a way that the height of this triangle is L and its base will be B1, B2. We have labeled this B1, B2, B3, B4 in that way. So when I will add all these areas or all the areas of this smaller triangle, then I will get the CSA of this portion. Now CSA or the area of this portion is nothing but the CSA of cone. Yes, so if I will able to find the area of this portion or area of this major sector, then that will give me the area of or CSA of cone. So let us try to find. We know that the area of that small triangle, it is nothing but half base into height. So if I want to find that CSA of cone, which is nothing but the area of this whole portion, so it is half, that base is B1 and height is L. Yes, now here height for all the smaller triangle will be same, but the base is different. Here it is B1, here it is B2, B3, B4 in that way. So I will add this till half. Suppose it is, if I am dividing it 100 times in 100 pieces, so it is B100 into L. Okay, now here half into L can be taken common to get B1, B2 plus so on till B100 here in bracket. Now here B1, B2, B3, B4, all this, if you will see this, yes, this is nothing but the circumference of a circle or the circumference of a circle, which is base of that cone. Yes, here B1, B2, B3, these small pieces, yes, together this addition of this whole together is nothing but the circumference of the base of that cone. So this will give me half L. Now here we have seen the radius of that, it is R, and circumference we know it is 2 pi R. So the addition of all this bases B1, B2, it is the circumference of the base of that cone. So it is 2 will get cancelled. What we are getting is pi RL, and this is nothing but the CSA of the cone. In that way, you can find the CSA of cone using this formula pi RL, wherein R is the radius of the cone and L is the slant height of the cone. We got CSA of the cone as pi RL. Now try to find the TSA of cone. Yes, TSA of cone is nothing but the CSA of cone plus area of base. Now area of base, that is nothing but the area of a circle, because here we can see that the base is the nothing but the circle of radius r. So this CSA is pi RL plus area of base pi r square. Yes. Now here pi and r can be taken common. If I will take pi and r common, what I am getting in the bracket is L plus r. Yes. So this is the formula to find the TSA of a cone, that is total surface area of a cone, is given by pi r in bracket L plus r, where r is the radius and L is slant height of the cone.
Finding the surface area of a sphere. In this module, you will learn to find the formula for the surface area of a sphere. Recall that the curved surface area of a cylinder is the product of the circumference of its circular base and height. We'll use this information in an activity to find the formula for the surface area of a sphere in terms of its radius. For the activity, we need a sphere and a cylinder of equal radius. The height of the cylinder should equal the diameter of the sphere. We also need a pair of scissors, a roll of orange and red thread, a pin, a cutter and a black sketch pen. Use the cutter to divide the sphere into two hemispheres. Fix the pin on top of the hemisphere. Start from the pin and wrap the orange thread around the curved surface of the hemisphere to form a spiral. Mark the length of the thread and cut it at that point. Unwind the thread from the hemisphere and keep it aside. Now wrap the red thread around the curved surface of the cylinder to form a spiral. Mark the length of the thread and cut it at that point. Unwind the thread from the cylinder. Compare the lengths of the two threads. We can see that the length of the red thread is 2 times the length of the orange thread. This shows that the curved surface area of the hemisphere is half the curved surface area of the cylinder. If the radius of the hemisphere is r, then the radius and height of the cylinder is r and 2r respectively. So, the curved surface area of the cylinder is 2 pi r into 2r. The curved surface area of the hemisphere is 2 pi r square. The total surface area of the sphere is 2 times the curved surface area of the hemisphere. Thus, The total surface area of the sphere with radius r is 4 pi r square. This is the formula for the surface area of a sphere. In this module you have learnt surface area of a sphere with radius r is 4 pi r square.
Given here the CSA and TSA of all the solid shapes, cuboid, cube, cylinder, cone, sphere and hemisphere. Copy all these formulae in your notebook systematically. The CSA of cuboid is 2 in bracket L plus B into H. TSA of cuboid 2 into LB plus BH plus HL. Then CSA of cube 4A square, whereas TSA of cube is 6A square. CSA of cylinder 2 pi RH, whereas R is radius and H is height of cylinder, and its TSA is 2 pi R in bracket R plus H. Then CSA of cone is pi RL and its TSA is pi R in bracket L plus R. Then sphere, TSA or surface area we are calling it. Sphere don't have CSA and TSA like that. The surface area of sphere is 4 pi r square, where r is the radius of the sphere, and for hemisphere CSA is 2 pi r square, whereas TSA is 3 pi r square. Let's start with the sums from exercises. Exercise 13.1, first question. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box and the cost of sheet for it if the sheet measuring 1 meter square cost rupees 20. Yes, there are two sub questions. First of all, you have to find the area of the box, ignoring the top, and then the cost. So the dimensions of cuboid, if we will see at that dimensions, length, breadth and height are different, it means that it is a cuboid in shape. So given that length is 1.5 meter, then breadth is 1.25 meter and height, it is given deep, it means that it is height 65 centimeter. Now length and breadth are given in meter, whereas height is given in centimeter. So first of all we will convert this height into meter. We know that 100 centimeter is equal to 1 meter, so divided by 100 we'll get 0.65 meter as height. Now you have to find the area of the sheet required if the top is opened. Now top is opened means that cuboid is looking like that, wherein you are having the top is open, it means that you are having only 5 faces. Okay, so there are two ways to find the area of the sheet required. The first one, either you find the TSA of the cuboid and then subtract the area of the top, then you will be getting the area of the remaining 5 faces. Or else the second method, you just try to find the LSA of cuboid and then add the area of the bottom to it to get the area of that 5 faces. So I think the second method is easy, because herein to find the LSA is easier than to find the TSA, because in TSA we see the formula 2 into LB plus BH plus HL. Yes, whereas LSA the formula is easier. So we will try to find with that. So here area of sheet will be equal to that LSA of cuboid plus area of bottom. Yes, so here to find the LSA, it is 2 into L plus B into H plus area of bottom. Now here if you will see this bottom is rectangular in shape, of which the length is L and the breadth is B, and this is the height. So L into B will give you the area of bottom. So it is L into B. Yes. So just substitute the values. 2 into length is 1.5 plus breadth is 1.25 into height is 0.65. Yes, plus 1.5 into 1.25. Let's try to do these calculations. This will be 2.75 into 0.65 plus this multiplication. Let us try to do. It is 1.875. Now we'll multiply this. 2.75 into, it is 1.3 and the plus 1.875. Yes, just again try to multiply this. One, two, three, 3.575 plus 1.875. Now add this. So in that way we will get the area of sheet required as 5.45 meter square. Now we need to find the cost of the sheet required. So knowing the area and rate, you can able to find the cost. Here rate is given as rupees 20 per meter square. Yes, we know that cost is equal to area into rate. Yes, so area is 5.45 and rate is 20. Try to multiply this. Yes, so what is the cost? The cost is rupees 109. So in that way, knowing the formula and understanding the question properly, we can apply the formula to get the required things or required area and cost.